about storage and retrieval. Okay, so we're going to start today's lab with this. Okay, incredibly simple. We have what is known as a data type or type. Okay, and we have what's known as a name or a identifier. Okay, either answer in an exam would be suitable. Now, I can modify this, and I can modify this in different ways, so I can have different data types. Okay, so I've got int star there, I've got int, I've got char, I've got float, I've got float star, all different types of data types. And I can also change the identifier. So be something long, num of students. Okay, so we've got the data type and we've got the identifier. The data types include pointers, okay, but we've also got another data type that doesn't quite fall into this, which has two parts. Okay, I'll put D. Okay, this data type takes 2 bits of information, the data type of the array and the fact that it is an array. Okay, and then we've got the identifier in the middle. Okay, we all happy with that? Yes, no, maybe, I don't know. Can we hear me? So as I said, try and even if it's a silly question or a quick question, just answer so I get that feedback. Okay, that's what I really want today. Okay, cool. So this is probably the biggest mistake that people make when using this new data type that we're going to use. So firstly, defining and declaring. Okay, so what we're going to do right now is we're going to define a data type. So we're going to say, we want this data type to look this particular way. Now, I'm going to actually, because I think this lab is kind of good and they are very interested in networking from what I remember last week. So, all right. So, where is it? There it is. All right. So, often on a computer, we need to describe more complex data structures. Okay. So, for example, if you're making a game, you might need to describe an actor or an object or some kind of power-up. Now, with those kind of data objects, you can't describe them just by one int. You can't just describe them by one float, okay? In operating systems, you need to describe things like files and folders and programs. You cannot describe these by a single int, okay? In networking, for example, I will show you an example because I know you're interested in this stuff. So for example, here we have some of the data types that we use in networking when using sockets. Sorry about the low resolution. But for example, if we've got a socket, we need its address, we need its port number, we need a label, okay? So it's not just one int anymore, it's not just one float, but it's a collection of information that we put together. Now, could we do it without this? Yes, we could. Would it be extremely horrible? Yes, it would, okay? So we could describe things with lots of arrays, which we did in the task where we did the water flow. For example, we store the lengths and the heights in two separate arrays. But what if we could just describe each pipe segment as one object or one data structure? Okay, and that's what we want to do today. Okay, so we want to be able to make a complex data structure and squish it all together so we can just describe it by itself. Does that make sense? Where's everyone else? Ramya, does that make sense? Cool. All right. So what we're going to do is we're going to start with a basic example. The first thing we need to do is describe what our data looks like. Okay, we can't use it until we've described what it looks like. Okay, so I'm going to describe a physical object, and my physical object is going to be a dog. So to do this, there is different ways that you can go about defining in different locations, but we're going to keep it extremely simple in this subject. Okay, if you are going to go on and do more C, you'll need to look at where you define your structs, but in this subject, we're just defining them above main and keeping it nice and simple. Okay, so what we're going to have is our includes, we're going to have our struct definitions, and then we're going to have our function prototypes, and then we're going to have main. Okay, so just imagine that the includes are there, and I'm going to define what my dog object looks like. Okay, so I'm going to write struct dog, and I need to define what data is important for this. Now, for the purpose of my task, I am creating a database for a vet, let's say. And the information they need is the age and the weight. Now, obviously, in a real vet's, you probably need a bit more information, but I'm keeping it simple. Then we're going to go to main. So previously we looked at different ways of declaring, and we saw that we could declare basic variable data types, we could declare pointers, we could declare arrays. Okay, so what we're going to look at right now is declaring our declaring a variable for our complex data type. So to start with, I'm going to use this data type. Now, this is where most students make the mistake. Struct dog 1. I know it's confusing, but you have to believe me and accept this. This is the type. Okay? Yes, there is a space in between it. That is perfectly fine. There is no such type as struct in this program. There is no such type as dog in this program. Struct is not a type, okay? Struct dog is a type, but struct by itself is not a type. It allows us to define complex data structures, but by itself it's not a type, okay? We also have an identifier, okay, or a name. Okay, and this is using the same rules that we just talked about earlier. Okay, this basic idea of we've got a type and a name. Okay, this is how we declare a basic struct. Now, what's great about this is this dog1, okay, no longer is just representing one bit of information, okay? It's storing 2 bits of information. It's storing the age and the weight, but we only need one variable. And this allows us to manage our data a lot more safe and a lot easier, okay? As I went with the water flow example, for the pipe example, you could have had the height and the diameter and the velocity and all that information all stored in one struct, okay? And that'd be a good practice for the second exam, okay? Try and redo that lab, but use structs, okay? So how do I put information into it? So the first way is on initialization. So on initialization allows you to put information in using the curly braces, and we can put the age and the weights. Now we can only do this on initialization. We cannot do this after initialization. To set the values after initialization, what we do is we write dog1 dot age becomes 2. We've got our variable on the left-hand side, meaning we're doing information storage. Okay, so we're taking this 2 and storing it in the dog's age. We can also get the dog's weight. Okay, and I could store something like 4.1. So now this dog has an age of 2 and a weight of 4.1. We can also do information retrieval. So for example, I could go int age of dog becomes dog1.age. Okay, so I can go get that information and use it in a calculation and then store it. Does that make sense? Or is there any questions? So wait for everyone to say yes or no or have a question. And this covers the basics, so don't ask about pointers or arrays yet, because we're going to get to that. All right. So now we've got this. So we've got the basics out of the way. We know how to do the basics. We can do initialization, we can do information storage, and we can do information retrieval. Okay. So that's fairly good. So now we'll go and have a look at pointers. So pointers. So I've got my struct dog1, okay, and dog1 dot age is 4, dog1 dot weight is 2.1. Okay. Now, if I want to point it to something, so if I've got an int a and I want to store the address of this, what type do I need? If I want to store the address of this, what type do I need? Everyone. Everyone. What type? Not pointer, not int. I want to store the address of A. What type do I need? So I'd need an int star, okay? So if I want to store the address of A, I need an int star. Okay, not an int. I don't know why everyone's writing int. We need an int star to store the address of A. Okay. So if we wanted to store the address of A, we require an int star. Okay. An int star says a pointer to int. Okay, that star means it points to an int. All right. So if I wanted to store the address of dog1, what type would I need? So I want to store the address of this guy. No one's quite got the right answer. Capitalization is important. Still no one. Hey, we got a correct answer. Beautiful. So we need a struct dog star. Remember that this whole thing is the type. We cannot separate these. Struct is lowercase. With our structs, we usually define the following word with a capital so that we don't confuse it with a variable. Okay? All our variables are lowercase, so we define this as an uppercase so we don't confuse it. So I'm going to call this dog pointer. And it's allowed to hold the address of a struct dog. Okay. So we've got our data type. We've got a pointer to a struct dog. Okay. We've got the identifier or the name dog pointer, and we're storing the address of dog1. Remember, this is a struct dog. Adding the ampersand adds a star to the type. So we've got struct dog star gets stored in a struct dog star. And this is perfectly good. Now, the difficult part. How do we dereference it? So, dereferencing. So, this is a mistake that a lot of students can make, and it's understandable, and it's because of order of operations. So, some students will do this. Age becomes 8. Now, the problem with this is that this actually has precedence, meaning it will come first, not the dereference. Now, the address is just an address. It doesn't have an age. There's no age of an address. And because of this, this won't work. So when we dereference a struct, we need to put brackets around what we're dereferencing. Once we've dereferenced, we've got our dog and we can get its age. Okay? Does that make sense? And I'll show you the shortcut. So all we're doing is dog pointer has the address of dog1. We go to where it's pointing, and then we grab its age. Okay. Now there is a shortcut. Because this operation is used a lot, and obviously we don't want to have to add brackets all the time, because that can be kind of dangerous. What we can do instead is we can write dog pointer dash greater than, so it looks like a little arrow, age is 8. These two lines are the same. Basically, that little arrow symbol does a dereference and then gets the value, okay? So this gets around the precedence issue, all right? So you can use either one of these if you like. We're happy with that. If you're happy, just say happy and then we'll get on to arrays. Cool. All right. So now we're going to have a look at arrays. Okay. And our arrays are just like our arrays before. So if I've got an array, I just write something like this. Okay. I've got the type of the array and the fact that it's an array, and then I've got an identifier. So I need the type, so struct dog. Remember that these two words together make up the type. They shouldn't be separated. I shouldn't ever see dog in the program, and I shouldn't see struct in the program by itself. That goes with today as well. I'm going to call it dogs. I'm naming it plural because there's lots of them, and I'm going to put 3. Now what I can do is just use it like a normal array. Dogs 0.age is 4. Now you'll notice that it's not dogs.age 0. It's 4. That's wrong. Okay, why is it wrong? Because we're talking about the first dog, and each dog has 1 age. Here, we're saying all the dogs.age, and here we're saying, I don't even know, the first age of all the dogs, which doesn't make sense, okay? So the array is not of what's in there. We could have an array in here, which we'll look at today, okay? But you can see that we have an array of dogs. Okay, so we get the first dog, we get its age, and it's 4. We can do that with the second one. Dot age, 6. Dogs 2, dot age is 7. Okay, and that gives us an array. Does that make sense? Awesome. So this is all pretty well and good, but data types aren't usually, we're not going to really get much if they're just 2 ints or floats and stuff like that. Rather, we're probably going to see more complex things than this, such as arrays, pointers. We've got basic, and we can also have other structs. Okay? So we might not just have ints and floats in here, but we might have arrays, we might have pointers, we might have other structs. And this is what we're going to see today. We're going to have a family of different types inside of our structs. And we're going to see the full power and usefulness of this, because we can have a huge, and even today it's really tiny, but we can have huge data types that express very large bits of information, okay? So let's start the lab. So we're going to do it together. Well, no, you can listen and I'll do it. So what I'm going to do is, I'm going to get that there. I'm going to get the lab. Where did I put the lab? I did get the lab. There's the lab. This is the lab? Yeah, this is the lab. I'll put this here. Hey, get in the corner. No, don't do that. All right, so let's first understand what this problem is, okay? That's the most important thing of a professional, is firstly understanding the problem, okay? I see a lot of students that go to the interviews and stuff like that, and they'll focus on the problem solving and not actually look at the problem themselves. Same with the assignments and stuff like that. Always read the problem first, no matter what, okay? Most important thing. You've probably all done something like system design and methodologies. Most of the time, we're spending most of the time on the problem. The coding is the easy part, okay? Think about, so when I developed these labs, I didn't just go and write the code first. What I did is I first designed the problem, designed the solution, and then quickly wrote up the code and then turned it into steps. I spent most of the time, probably 80% of the time, designing, okay? This is what you should be doing, okay? Focus on the problem and the code becomes really easy, okay? So basically what we've got here is we've got a belt and we've got two gears, okay? And what we're trying to do is a customer, okay, is selecting a belt. And we're going to work out how long of a belt they need for their system, okay? This is a timing belt, so something for a car or a bit of machinery, okay? And we're going to calculate what size they need for their vehicle or machine, okay? We've got 3 different types of belts, okay? And they have different pitch, the different height, and different tooth height, okay, based on this diagram. Now we could add more types easily to this problem. You'll notice here that we've got a complex data structure, okay? We've got these belts that have 4 bits of information. I cannot describe one of these belts using a single int, or a single float, or a single car, or a single string, okay? So you can see here how helpful our structs can be in describing more complex bits of data. Because if something as simple as a piece of rubber that goes around some gears, okay, can't be described by a simple int, okay? Does that make sense? And you're going to see this in real life everywhere. All good? All right, let's keep going. Blah, 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 blah. All right, we've also got the diameter of the gears and the distance between them. So what I've done for you is I've set up these data structures. So we've got the gears, okay? The gears have a diameter and they have a pitch. Okay, remember the pitch is just the distance between them. Okay, they have to match up to the belt. You've got the belt itself, which is this information here: pitch, belt height, tooth height. This is the type of the belt, but the belt itself, okay, is going to have a length, and it's going to have a number of teeth, and then it's going to be of a certain type. Now you can see that you've got a struct inside of a struct here. Okay. So we've got the gears, we've got the specifications for the specific belt, and then we've got the types of belts, but then we've also got the entire system. Okay. The system is made up of 1 belt, 2 gears, a distance between them, and some slack. So that means all belts aren't going to be perfect. There might be a little bit that's a little bit loose. Okay, and that's the slack. Okay, so we've got this complex data structure here that we're going to draw up, and I'm going to give you a really handy diagram that you can use during your lab. And I want you to be able to design these yourselves as well, because this skill of designing your own structs, if you're doing C, or designing your own objects if you're doing Java or C++, is extremely important, okay? It doesn't really matter what language you're doing. This is how we describe data, and you need to know how to do this if you're doing anything computer related in this century, okay? So we do need to know how to do this. So we're going to start the lab by so today's lab, we have 3 libraries we're going to include. We have the standard IO, which is our normal one. We've got math.h, and we also have, why can't I do this? Sorry, I'm concentrating on too many things at one time. We also have the string.h. I'm going to add my main. Even though it is week 10, I think, I'm going to save and compile it, okay? Because I'm not going to take the risk of it not compiling later, okay? I want to make sure these paths are correct. So I'm going to quickly compile and just make sure it compiles, okay? And you still need to be doing that, okay? So I know that this part works, so I'm going to go on to the next part. So the next part is I'm going to define a macro called pi, which will just help us out. So we've got a macro, which we've seen before. And under that, I'm going to declare my structs. So I've got 3 structs that I've given you in the document. Okay. Now, big thing with the structs, there is a semicolon at the end of the definition. So remember, we're defining them here. We're not declaring them. We're just saying this is what they look like. So if I had to define a student, I would say a student looks like a student number, a student name, a student email address, blah, blah, blah. Okay? I'm not talking about a specific student. I'm just saying this is their template. This is how they should look in a database or a system. Okay, so I'm going to put these together. The other thing is you can probably notice how I'm writing the code as well. I'm filling in the blanks rather than just writing down the page. This is important. The way that you should be writing the code. So I'm going to put these together, and then we're going to have a look at something in a sec. Now you can see in this one here that I've got this type inside of this struct. Okay, so remember that this is the data type. Okay, these 2 words make up the data type. This is the identifier. Don't get confused by that. Right? It is the most common mistake that we see on exams, and also this lab when submitting it, is students will write things like gear specs and there won't be any struct before it. Now, there is actually a way to rename your data types, but we're not doing that in this subject. We don't need that, okay? We would much prefer that you just know how to use structs and you understand that the data type is this, rather than confusing you and getting you to rename the data types, which I noticed that other courses sometimes do, and I think it's a bad practice because it's kind of hiding from you the fact that it is the data type, just to make it easier on the teacher, okay? We're going to keep it like this so you can learn, okay? So I've got that. I'm going to do a really quick compile, and then what I'm going to do is you'll notice that we forgot the last one. Oh shit. So what? Guess what? You're going to write it and you're going to put it in the chat. Okay. So in the group chat, I want you to write the definition of this what I want you to do is press this little code block, type it. To go enter, just press shift enter, and it will go down the page. If you press enter, it'll send. So just use shift enter. So everyone, write the definition. The prettiest one I'll choose. Everyone. So use shift enter to go to the next line. Once we've got everyone's, then we'll go on to the next part. So to stop it sending, just press shift and then enter, and we'll go to the next line. Oh, very nice. I can't see anything with that. Keep going. Okay, pressing enter. Very nice again. Yes, semicolon is important. I like the people who are indenting it as well. So let's wait for a couple more, and then we'll keep going. I'm going to steal. All right. So I've stolen one of them. Saves me typing. Enter it to the same level as mine. So we now have struct. Beautiful. And it compiles. All right. We're going to start writing the next line, and then we're going to go over to Photoshop, and we're going to try and understand what this line is all about, because there's a lot going on. Okay. So if you're still going, just keep typing your answer while I type this out. Good practice. Still didn't fix that this year. This auto. T10. 8. All right, so what I'm going to do now is I've got this line here, which is a little confusing, and I'm going to bring it over to Photoshop, and we're going to have a chat about it. So, let me go steal it. So, where's Photoshop? Photoshop is here. So I'm going to go down a little bit, paste this, and what I'm going to do is I'm going to get rid of all this because I don't care about this. Move this guy up. Move this guy up. Here. All right. So we have this. Now, as I said, we want to keep it simple. So let's keep it simple. So int a 3 1 2 3. Oh, that is the worst looking 3 ever. 1 2 3. Okay. Does everyone understand that line of code there? Yes, no, maybe. Awesome. So here we've got two really nice simple lines of code. We've got int b becomes 2. We've got the array a is initialized with 1 2 3. Now we saw earlier that we can initialize our structs. Okay, so I can put all that information right at the start. Okay, so when I've got an array, I can do the same thing. So you can see here that we've got struct, belt type, square brackets 3, and then I've got brackets inside. Now the brackets inside are talking about each struct being initialized, and the outer brackets are talking about the array. Okay, just like this. Okay, so here we've got 3 belt types, and instead of 1 2 3, I've got one of these, one of these, and one of these. Is that all good? All good? Cool. Cool, cool, cool. Let's keep going. All right. All right, create a variable to store 5 characters. Okay, so the variable that can store 5 characters would be a car. Then print to the screen, select the belt type, and store the user's input. So I know this is the so user's belt, let's say, and make it 5 long. Okay, and I'm going to store the user's input. Now, to store a user's input, I'm going to need something we haven't used that much. This is a string. Okay? A string is a collection of characters ending with a null terminator. Okay? See the lectures or the assignment video. Okay? So it ends with a null terminator. Okay? So the user will enter some values and we'll get a null terminator at the end. Okay? So AT20 is 5 characters long. AT10 is 5 characters long, and AT5 is 4 characters long. And this is why we need it to be 5, okay? Because AT20 null terminator. We can't see the null terminator, but it is there, okay? So keep that in mind, all right? That's really important. Okay, the string has to have an end, or else we get segfaults. or other random shit happen. Okay, so we've got the user's input, blah, 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 blah. I've just saved it, so I'm going to compile it. Unused variable, that's perfectly fine. Copy your search function from lab 7. Cool, so let's go to lab 7. Where's lab 7? Lab 7, search, 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 search. So I'm going to copy that search function that you made last time. I'm going to put it below. Now, what we're doing here is we've got the definition of all the types here. Okay, so I'm saying to the customer, which one would you like? Would you like an AT5? Would you like an AT10? Or would you like an AT20? And I need to find those. Okay, so when doing this, don't imagine that there's going to be 3. Imagine that there's 300. Let's say there's 3 million. Okay, most databases aren't going to be the size 3. Okay, we're just keeping it simple for the lab. Okay, so we need to search through and find it. Okay, so we need to see, can we find the AT5? Can we find the AT10? Can we find the AT20? If we find it, it should return its index. Okay, so I don't want the whole struct back. I just want to know where it is. Is it in index 0, 1, or 2? So if the user enters AT10, I should get a 1 back. If the user enters an AT20, I should get a 2 back. And if they enter an AT5, I should get a 0 back. I want its index. Now this search function's a bit crap at the moment because it's looking for floats. We don't want floats. We want belt types. So I'm going to steal this and I'm going to change it. I don't want floats, I want belt types. And the search value, we want a string. Now a string is a char star, so we're going to change that to a char star. So we're going to search for AT5, AT10, or AT20, and we want to search through our belt types. Our pointer can no longer be a float because we're not looking through floats anymore, so I'm going to change that to a belt type as well. Let me get here. Now strings, if we compare 2 strings, so say hello and hello, they're not equal. Okay, they're not equal at all because it's comparing their memory addresses. Remember, they're pointers. Okay, so arrays are always pointers, so we can't compare them that way. So how do we compare them? We use a function called string compare, which takes 2 arguments. Okay, so I can do something like hello, hello. And if they're both equal, then string compare should give me 0. Okay, so this is how I compare strings. So the string that I want to compare is going to be my dereference pointer position, not the name, not the name. And I want to compare it with the search value. And we're done. Okay, so that's my search done. I'm happy with that. I probably should do one more thing, which is put a function prototype. Okay, so we've got the function prototype, we've got everything there. Do a quick compile, make sure everything compiles, everything compiles. Okay, so now what I'm going to do is I'm going to call the function. Okay, I want to get that index. So I'm going to grab my search function. And I need to pass it the information. Now, what do I want to search through? Tell me, what do I want to search through? What's the array that I want to search through called? In the chat. Belt types, beautiful. Okay, so the array I want to search through is called belt types. How many belt types are there? Belt types are there? 20112669. How many belt types are there? Yeah. Okay, so there's 3 belt types. And what are we actually searching for? Yeah, so we're searching for the user's belt, the one that the user entered. Now, what do we get back from the function? Big question, everyone. What do we get back from the function? It's not the address. The index. Okay, remember, if we want an AT5, I should get 0 back. If I want an AT10, I should get 1 back. If I had AT20, I should get a 2 back. So, I need a new variable for that, so I'm going to call this belt index. Okay, and I'm going to get that back. Now, if it's incorrect, I should get a -1 back, and you can deal with that later by putting an if statement here, or you can put a while loop or something like that and deal with that case. But let's not worry about that right now. All right, so now what I'm going to introduce is the customer belt specs. So struct specs. And this is the customer's belt. Okay, so it's no longer the type. So I'm going to add the type to their specs. Now remember, the specs has the type in it. And I'm going to do that by going customer belt specs dot type comes belt type, the one the user wants, which will be the one at that particular index. Okay. I'm going to set the length to -1. Why am I setting it to -1? Because we'll do that later. Okay. And I just want to put a value in there so that I know what it is. Okay, so if it prints anything other than -1, I'll be really worried. All right, so we've got that. And what we're going to do is we're going to jump back into Photoshop. Okay, so I'm going to try and get all of this in. I get them all in at the same time. Probably not. It doesn't matter. Give me 2 seconds. 2 seconds. 2 seconds. 2 seconds. Where? Oh, beautiful. That's what I want. So I'm going to steal this. Let's keep going down. So we've got our definitions here. Put those over here. And I'm going to get that little bit of code that I've written, which is here. Put this here. Put this here. Beautiful. All right, so now let's see what we've actually got. And I'm going to draw a slightly different diagram. And this diagram will help. Okay, and we're going to do a really big one of these, which is going to be really hard. All right, so we have this struct belt specs, customer belt specs. So customer belt specs. And this is a way that you can design your own diagrams. I mean, your own structs. So I'm going to take that, and that goes into type, number of teeth, and belt length. The type also continues on and goes to belt name, belt pitch, belt height, and tooth height. I'm going to put a dot here, and I'm going to put a dot here. So, how do you use this diagram? So the way you use this diagram, if I wanted the number of teeth, customer, belt, specs, dot, num, teeth. So my question to you is, what if I want the belt pitch? How would I get that? Go. Excellent. Okay, so we've got customer belt specs dot type dot belt pitch. So this is how you use this diagram. Awesome. So we understand how to use this. It's not uppercase, it's lowercase. Okay. We know that because it's a variable. Okay. All of these are lowercase, as you can see, because they're variables. So just be careful with your casing. All right, so let's keep going. So we're now going to create an array. So we've got struct year specs customers gears. So, all right. So we've got 2 gears. So we're creating 2 gears. We're going to ask the user for their gears. What is the diameter? Gear. Meters. We're going to scan it from the user. Now with this scan, we're looking for an int. So I need to pass an address. And the address I want to pass is not the whole struct. Okay, I don't want to store the diameter in the whole struct. I want to store the diameter in this particular one. So I need to use brackets here. I think I put too many brackets. Okay, so it's going to be customers gears, index 0 dot gear diameter. I also need the pitch. Now, logic would tell you, okay, if the belt has a certain pitch, then the gears have to have a matching pitch, or else the belt won't match with the gears. Okay, so that little gap, okay, has to match, or else the gears and the belt they won't connect. Okay, it'll be really sad. All right. So we've got the pitch. We're going to steal that from our type dot belt pitch, which you just wrote. Okay, so you know how to get that pitch. You just told me how to get that. Okay, I'm going to save that, compile that, not open up to server. Customer gears undeclared. Why is it undeclared? Did I do a spelling mistake? Probably. Oh, that's why we compile. Cool. Now I know that's perfectly fine. I'm going to copy and paste that and do the second gear. Second gear. So we've got the second gear done. Okay, as simple as that. All right. So we've got 2 gears. We've got 1 belt. We've got the specific belt. Now we need the system. Okay, so we're going to create a system. We've got this struct timing belt system here, and we're going to call it customer system. Okay. And what we're going to do is we're going to store everything in it. So we're going to store the belt in it, we're going to store the gears, we're going to store these other two variables as well. So I'm going to do customer system dot belt is going to be customer belt specs, and customer system dot gears 0, so index 0. This is now an array inside of a struct, and not only is it an array, it's an array of structs. So you're getting the full experience. Don't get too excited. All right, so we got gears 0. System gears. And then we're going to see something really powerful about this whole system that should get you very excited. Okay. So we're just going to do this little printf here, just to get the center distance of the user. What is the distance? And we're just going to scan that user. Once again, you'll notice that we are using the brackets because we don't want the address of the whole system, we want the address of the center distance. Okay. So we've got that. I'm just going to save and compile, and then I'm going to bring it into Photoshop, and we're going to create an awesome diagram. Okay. So what we've got here is quite powerful. We have one variable called customer system that describes the whole system. Okay, and we're going to see it, and we're going to see how powerful it is. Okay, so let's go back over here. I'm going to steal you. You're coming with me. Don't fight it. Come, behave. All right. So, no, behave. All right. I'm going to steal. No, actually, we don't even need that. I might just steal. Actually, no, stuff it belongs to it. Don't even need it. All right. So, using your memory, we know that we've got. Now, I'll start at the top because I think it's probably easier. So we've got this variable called customer system. Okay, and it feeds into 4 things. Belt. You'll notice that I'm only writing the variable name. Okay. Gears. Center distance. And belt slack. Now, our belt we saw before has type, it has num teeth, and we have tooth height. Now type, now obviously you can make this a bit neater if you want for yourself, but I think you get the point. And you can see that there's one single variable holds all of this information. So we're going to see some examples of this used. Probably should. So, probably made it a bit too messy, but oh well. So we've got gear diameter, gear pitch, gear diameter, and gear pitch. And then I'm going to add my dots, and I'm also going to add something else this time. I need to choose a good color. So I've got a dot, I've got a dot, I've got a dot, I've got an index 0, and then a dot, and I've got an index 1, and then a dot. So let's say I want the belt pitch. Customer systems, dot, belt, dot, type, dot, belt pitch. Let's say I want the diameter of the first gear. Customer system, dot, gears, the first one, so index 0, dot, gear diameter. Okay? So you can use this diagram, and from one single variable, you have everything. Does that make sense? And that's the first task done as well. And then we'll go on to the second task. Do we want to do the second task? No, we don't. I'm sick of me talking. Okay. Any questions? And then we'll talk about the second task. There's a couple of little things that I want to talk about. No, you don't want me to do the second task? All right. So, now, where the fun starts. So, you're all nearing the end of this course. You're all masters of IT or engineers. And so, guess what? You've decided to get into technology. What is there a lot of in technology? Maths. All right, so because of that, we've got a bunch of maths. Now it's not too difficult, okay? We've got some basic algebra, but here we've got something a little bit more interesting. And it's something I want to cover because I've seen, mostly undergrads have seen it in their first year engineering maths, but I've seen some students that might have a, I don't know, haven't done linear algebra. They might have not seen this before, and that's okay, okay? It'll make sense in 2 seconds. So I'll just show you. So in maths, there's some special brackets, okay? And they look like this, okay? And this is called the ceil function, okay? Talking about mathematical functions, this has nothing to do with programming, okay? And the floor function, okay? Now, the ceil function will take a number and it will round it up no matter what the value is. So for example, 1.1 will become 2. 1.001 will become 2. 1.9 will become 2. The floor function, on the other hand, oops, it will always round down. Okay, and that's all that is. Okay, pretty simple. Does that make sense? Is there any confusion about that? So if it all makes sense, just say it makes sense, and then we'll move on from there. Cool. And this is really important because you would have noticed that if these were brackets, this formula would make no sense because they just cancel out. Okay. So basically it says here that the brackets is the ceiling function. This maps a real number to the smallest following integral, which is 3 or 2 or whatever. In C, you can do this using the math library. The function is called ceil. It's just ceil and then put the number in it, and that's it. Okay, it's a very easy function to use. Got a little bit more maths, and an worked example, so you can go through the worked example if you get stuck or you're getting wrong values. Okay, remember you have printf. I see a lot of students that write this huge mathematical formula and then they're like, oh crap, I don't know why it doesn't work. Have you tested it? No. Test it, okay? Test it. I give you this worked example for that reason, okay? The reason I give you this worked example is you can use some really nice simple values, print out the values. Let's say you're not getting 379, so you go and do it again and you realize that your problem's here, or maybe your problem's here, or maybe your problem's here, or maybe your problem's here. All right, so blah, 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 blah. All right, so we're going to create two functions. Now you notice this, look how many steps there are. Oh crap, we're running out of steps. Didn't want to give you too many steps. All right, so we're going to add two functions. The first function, a little bit shit, and you'll understand why very quickly once I show you the second function. So we've got struct, timing, system. It's independent from main. That's why I haven't called it customer system, because I can use it for whatever I want. I could use it for a customer system, I could use it for a receipt, I could use it for anything, okay? I try and keep my functions independent from main. I try and keep them independent as much as I can so I can use them for whatever I like. For example, printf is not called prompt user because we can use printf for lots of different reasons, not just for prompting a user, but for outputs, for a whole heap of reasons. It's just to print formatted, okay? Keep your functions generic as much as you can, okay? It will help you design better code, better systems, better databases, better networks. Keep your functions just generic, okay? It means you can reuse them wherever you like, and other people can use them that are working with you, and it'll all make sense. So let's get into that practice. All right, so print system. So basically we want to print the system. This is the format we want. So some of this stuff is just hard-coded straight in. So we've got a new line, and we've got dash, and we've got system. And then we get to the next line, and we want to print the center distance. So printf, blah, 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 center distance, colon. We've got a floating point number with 2 decimal places. So percent F. We've got millimeters, 0.2 for two decimal places. Now we need to work out what goes here. Now we've got this system. We're going to call the function, okay? So we're going to call the function, and we're going to pass the entire system. Okay? So this means inside this function, we now have, oh shit, where'd my diagram go? So we now have, we now have not customer system anymore, but system. And that's the only difference. And so if I wanted to get anything, you already know how to get it. So if I wanted to print out the belt pitch, I'm just going to do system.belt.type.belt pitch. If I want the diameters of the first gear, system.gears 0 dot gear diameter. So here, what do I want to print? I can never remember. I want to print the center distance. Now that one's probably easy. So system dot center distance. and so on and so on and so on and so on. Cool. The other one is a little better, and this is the way that you should probably do structs when using functions, and you will see this quite often. Okay, you'll notice that we pass not an entire struct, we just pass the pointer to it. This is a lot better memory management. Okay, if you can pass the address of something really large, do it. Don't pass the entire struct if you don't need to. Okay, I wanted to show you the difference, but definitely passing the address is much, much, much better. Okay, it's much better in terms of memory management. Okay. So here we have a pointer. Oh crap, what do we do? Well, let's go back to our diagram. So how do we get to our diagram? We get to our diagram, beautiful. So this time we don't have system, we have, I've lost my pen again. So this time we don't have system. Oh, why is that on that? Why? All right, so this time we don't have system. We have system pointer. Now we can't go system pointer dot because system pointer is an address. An address doesn't have a gear. An address doesn't have a belt. The address doesn't have a center distance. The address doesn't have a belt slack. So we have to, what do we have to do? Tell me what we have to do. If you want to get values from a pointer, what do we have to do? Dereference, beautiful. So we need to dereference this. How do we dereference something? What symbol do we use? Only 2 people know how to dereference. Come on, come on, come on, come on. Who's still listening? Beautiful. So we need dereference uses star. As I said before, we put it in brackets, so we only dereference the pointer. Okay? And that's the only thing we need to dereference. So if I want to get the belt pitch, it's just going to be star system pointer dot belt dot type dot belt pitch. Okay? Once I've got that point, I don't need to dereference the next thing because I'm actually getting the belt. Now, as mentioned earlier, and also mentioned in our chat, there is an alternative. Instead of this, we can do this instead. System pointer, and then instead of a dot, we have this arrow. They're your 2 options. So I will copy that into the chat for you. And I'll mention 2 other things, and then you can start the lab, and you should finish it off early because I'm pretty much giving you the answer to everything. All right. So, a couple things. Where's the lab? Where's the lab? Where's the lab? Where's the lab? All right. Don't forget storing. You're storing the length, you're storing the belt slack, you're storing the number of teeth. You've got the places to store it in your struct. Okay? The next thing is, this formula is long. Don't be afraid to break it up into 3 parts. Do this part by itself, do this part by itself, do this part by itself, and then add each 3 parts together. Okay? If you have some giant equation and you say you can't find the mistake, break it up, okay? You don't have to do it all in one line. Doing code in one line is not helpful if it's not working or not readable, okay? There is no harm in creating another variable.